To protect the environment, it is important to minimize the amount of water that enters the 4 damaged reactor buildings at Fukushima Daiichi. We are planning to create a frozen barrier around the perimeter of these buildings, forcing water to flow around them. Although we sometimes refer to this as an ice wall, it is really a barrier of frozen soil. Fukushima Daiichi sits between mountains and the sea. When it rains, surface runoff is blocked by physical barriers, but most rain becomes groundwater. The ice wall is part of our plan to keep groundwater out of the reactor buildings. Currently, 400 tons of groundwater enter the reactor building basements each day, and this accumulating water must be treated and stored. It is essential to reduce the groundwater inflow. The reduced burden on the treatment and storage systems will permit us to clean contaminated water currently being stored and, eventually, will reach the point where the daily capacity of our treatment system exceeds the rate of inflow, dramatically reducing storage needs. The ice wall is part of a comprehensive approach, including a bypass system that we explain in a separate video. The goal of the ice wall is to freeze the entire perimeter around the 4 reactor buildings. This is an innovative use of a technology that has been successfully used to prevent the intrusion of water when constructing tunnels. This represents its first use to prevent long-term water intrusion into a nuclear facility. We will create an impermeable barrier by freezing the soil itself all the way down to the bedrock that exists below the plant. When groundwater flowing downhill reaches this frozen barrier, it will flow around the reactor buildings, reaching the sea just as it always has, but without contacting the contaminated water within the reactor buildings and without becoming contaminated itself. To freeze the soil, we will use a technique similar to that used in ice skating rinks. Pipes are sunk into the ground at fixed intervals. The coolant is circulating through the pipes and will gradually freeze the surrounding soil. As you will see in the next animation, a key advantage of using this frozen soil approach over a constructed barrier is that it more readily accommodates underground obstacles. As you see here, there are many underground pipes and other obstacles near the reactor buildings. Freezing the soil creates a tight seal that could not be obtained with a constructed barrier. And here's why it's important to keep that barrier as close to the buildings as possible. This red line is where we would have to build a more conventionally constructed barrier to avoid underground obstructions. The flashing area shows the enlarged space on which rain would fall and increase the amount of water that has to be stored. The ice wall is a government-sponsored project being carried out jointly by TEPCO and Kajima Corporation. It is currently under construction, and we plan to begin freezing the soil in March of 2015. When fully operational, the ice wall will be a key element of our continuing strategy to protect the environment from contamination while we undertake the important work of decommissioning Fukushima Daiichi.